This video explores a theory suggesting that a particle is spatially confined light, unifying energy and matter through the nonlinear properties of the vacuum. Both matter and confined massless energy exhibit inertia, which is a resistance to acceleration. For matter, this is due to molecules impacting the advancing wall. For light, it is caused by a Doppler shift increasing the light's momentum when hitting the advancing wall, creating a pressure difference. This thought experiment suggests that inertia is a property of energy, not mass. During annihilation, total inertial mass remains the same, whether the energy is in particles or radiation. This leads to the question, are particles a form of self-confined light? Our theory proposes that a particle is spatially confined or trapped light. This requires two suppositions. First, the vacuum is an elastic, nonlinear medium. Second, light and matter are energy fluctuations or perturbations, superimposed on the medium's base energy level. Property 1. An elastic medium enables reversible energy storage. In a fully elastic system, energy stored through deformation is returned with no losses. This allows a perfectly elastic medium to store and release wave energy without dissipation, necessary for a stable, confined state. Property 2. A nonlinear medium allows for extreme property changes. Unlike linear elasticity, where stiffness is constant, in nonlinear elasticity, stiffness is a function of stress. At high stress levels, the medium can become significantly harder to deform. While the vacuum appears linear in current experiments, theory suggests it may be nonlinear above a certain threshold, the Schwinger limit. At this field strength, pair production spontaneously occurs, which is an inherently nonlinear response. We can simulate a nonlinear elastic medium using a 2D grid where pixels are connected by springs. The simulation uses RGB channels to define the medium's properties and potential energy. The simulation loop involves calculating field values, updating elasticity using a nonlinear equation, and propagating the wave. Simulation presents practical challenges like energy instability due to discrete time steps, which can cause the simulation to, quote, blow up. Another artifact is diagonal symmetry introduced by the calculation method. We must look past these numerical artifacts to see the underlying physics. The breakthrough came from trapping energy at high stress. Initial attempts failed, but an unexpected result using a negative exponent showed that trapping was possible. The new approach uses a high exponent and low coefficient to create a barrier at a high stress level. The genesis of a particle occurs as we release waves of increasing frequency into the nonlinear medium. Low-frequency waves pass through. Medium-frequency waves trigger nonlinear behavior but are unstable. High-frequency waves exceed the threshold, trapping a stable, localized particle. A surprising revelation is that the trapped particle is static stress, not an oscillating standing wave. The wave energy is converted into quote, frozen pure elastic potential energy within the medium, a result contrasting with initial expectations. The confined particle has a localized core and an extended field. The energy is not entirely localized. When moving or accelerating, the particle communicates its presence to the universe through this extended stress field. Charge emerges from a net positive or negative imbalance in the extended stress field, analogous to electric charge. Particles with opposite stress imbalance attract. Antiparticles are required due to the governing nonlinear equation being symmetric with respect to the sign of stress. The particle is stored static stress with inertia. While not an oscillating wave, its motion through the medium creates an associated wave. This suggests that the wave associated with a moving particle, as proposed by de Broglie, might be a consequence of the particle's motion.